Now let's go to the next room in the learning part, which is networking. What is networking? In this room, we are going to look at the fundamentals of computer networking. Networks are simply things that are connected. Take, for example, your friendship circle. You have some friends that you play football with, you have some friends that you're in school together, you have some friends that you enjoy going to parties together. That's just an example of network. You all are connected because of similar interests, hobbies, skills, and such, right? Now, networks can be found in all walks of life. A city's public transportation system, infrastructure such as the national power grid for electricity, meeting and greeting your neighbors, postal systems for sending letters and parcels. So these are just various examples of networks. Now, more specifically in computing, networking is the same idea. It is just dispersed on to technological devices. Take your phone as an example. The reason that you have it is to access things. We'll cover how these devices communicate with each other and the rules that follow. In computing, a network can be formed by anywhere from 2 devices to billions. These devices include everything from your laptop and phone to security cameras, traffic lights, and even farming. Networks are integrated into our everyday life, be it gathering data for the weather, delivering electricity to homes, or even determining who has the right of way at a road. Because networks are so embedded in the modern day, networking is an essential concept to grasp in cybersecurity. Let's take the diagram below as an example. Alice, Bob, and Jim have formed their network. We'll come on to this a bit later on. We can see the 3 of them communicating. Network comes in all shapes and sizes, which is something that we'll also come on to discuss throughout this module. What is the key term for devices that are connected together? That will be network. I don't know whether my internet connection today is just very slow and shady. I can't do much. What is the internet? Now that we've learned about network and how one is defined in computing, let's explore the internet. The internet is one giant network that consists of many small networks within itself. Let's say, for example, a university. We have different departments, different classes, different units, exactly. So that's just what the internet is like. So using our example from the previous task, let's now imagine that Alice made some new friends named Zane and Toby that she wants to introduce to Bob and Jim. The problem is that Alice is the only person who speaks the same language as Zane and Toby. So Alice will have to be the messenger. We can see the new friends and the previous friends. Because Alice can speak both languages, they can communicate to one another through Alice, forming a new network. Now let's go back a bit in history. The first iteration of the internet was within the ARPANET project in the late 1960s. This project was funded by the United States Defense Department and was the first documented network in action. However, it wasn't until 1989 when the internet as we know it was invented by Tim Berners-Lee by the creation of the World Wide Web. It wasn't until this point that the internet started to be used as a repository for storing and sharing information just like it is today. Now let's relate Alice's network of friends to computing devices. The internet looks like a much larger version of this sort of diagram. So we have like network 1, network 2, network 3, different devices in the network, and we have the internet. They are all connected to it. As previously stated, the internet is made up of many small networks all joined together, and these small networks are called private networks, when networks connecting the small networks are called public networks or the internet. So to recap, a network can be of 2 types: a private network, which are the small networks, and the public networks, which are the larger networks, right? So devices will use a set of labels to identify themselves on the network, which we'll come on to in the task below. Who invented the World Wide Web? Tim Berners-Lee. Good. The next task is identifying devices on a network. To communicate and maintain order, devices must be both identifying and identifiable on a network. What use is it if you don't know whom you are talking to at the end of the day? So devices on a network are very similar to humans in the fact that we have two ways of being identified. One, our name, and two, our fingerprints. Now we can change our name through the poll, but we can't, however, change our fingerprints, right? So every human has an individual set of fingerprints, which means that even if they change their name, there is still an identity behind it. Devices have the same thing, two means of identification, with one being permeable. These are one, an IP address, and two, MAC address. IP address, Internet Protocol address, MAC address, Media Access Control address, which is similar to a serial number. What is an IP address? An IP address can be used as a way of identifying a host on a network for a period of time, where that IP address can then be associated with another device without the IP address changing. So let's split this up precisely. We need to split up what an IP address is. Take for example this 192.168.1.1. We have the first octet, second octet, third octet, and the fourth octet. So an IP address is a set of numbers that are divided into 4 octets, and the value of each octet we summarize to be the IP address of the device on the network. This number is calculated through a technique known as the IP addressing and subnetting. So we'll talk about subnetting some other time, not today. What is important to understand at this point is that IP addresses can change from device to device, but cannot be active simultaneously more than once within the same network. What this means is that, let me give like a simple explanation. It's like you can just, if you have a number assigned to an individual, right? Someone else in some other time, in some other day, can also have that number assigned to them. But we can't have two people being assigned the same number at the same time in the same space. That's just what this means. So IP addresses follow a set of standards known as protocols, and these protocols are the backbone of networking. They force many devices to communicate in the same language, which is something we'll come up to another time. This room is just an introduction, so we don't want to bore you with all the nitty-gritty. However, we should recall that devices can be on both a private and public network, depending on where they are. It will be determined what type of address, IP address that they'll have. Is it a public IP address or a private IP address? A public IP address is used to identify the device on the internet, whereas a private IP address is used to identify a device amongst other devices. Now let's take the table and the screenshot below as an example. Here we have two devices on a private network. We have this desktop and we have this Symantec. We can see the IP address, we can see the private IP address, and we can also see the public IP address. They both have the same public IP address, but different private IP address. So these devices will be able to use their private IP addresses to communicate with each other. However, any data sent to the internet from either of these devices will be identified by the same public IP address. That's because they're on the same network, right? Good. So public IP addresses are given by your internet service provider at a monthly fee. As more and more devices become connected, it is becoming increasingly harder to get a public IP address that isn't already in use. For example, Cisco, an industry giant in the world of networking, estimated that there will be approximately 50 billion devices connected on the internet by the end of 2021. This is 2025. Wow. So far, we have only discussed one version of the Internet Protocol Addressing Scheme known as IPv4, that means IP version 4, which uses a numbering system of 2 raised to the power 32 IP addresses. So let's just calm down now. Just take it one after the other. We have IP addresses. We have public network, private network. So we have a public IP and a private IP. Now I'm trying to let you know that there are different versions of IP addresses. Just the same way we have different versions for our phones and some of our devices, right? Now we have IPv4 and IPv6. IPv4 can take up to 2 raised power 32 IP addresses. So that's about 4.29 billion, and that's not enough to go around. We know the number of humans on the planet. So you can see that there is a shortage. That's where IPv6 comes in, which is a new iteration of the IP addressing scheme to help tackle this issue. Although it is seemingly more daunting, it boasts a few benefits. It supports up to 2 raised to power 128 of IP addresses, which is about 340 trillion plus, resolving the issues faced with IPv4, and it is more efficient due to new methodologies. So in this picture, we have a screenshot of the IPv4 and IPv6. We can see the difference, right? Good. Now let's move to MAC addresses. Devices on the network will all have a physical network interface, which is a microchip board found on the device's motherboard. This network interface is assigned a unique address at the factory it was built at, called a MAC address, Media Access Control. The MAC address is a 12-character hexadecimal number that is a base 16 numbering system, split into twos and separated by a colon. These colons are considered separators. For example, we have A4 C3 F00 85 AC 2D. The first 6 characters represent the company that made the network interface, and the last 6 is a unique number. A4 C3FO represents the company that made the network interface, and the last 6 is a unique number. However, an interesting thing with MAC addresses is that they can be faked or spoofed in a process known as spoofing. This spoofing occurs when a network device pretends to identify as another using its MAC address. When this occurs, it can often break poorly implemented security designs that assume that devices talking on a network are trustworthy. Now let's take the following scenario. A firewall is configured to allow any communication going to and from the MAC address of the administrator. If a device were to pretend or spoof this MAC address, the firewall would now think that it is receiving communication from the administrator when it isn't. So places such as cafes, coffee shops, and hotels often use MAC address control when using their guests or public Wi-Fi. This configuration could offer better services, that is, a faster connection for a price if you are willing to pay the fee per device. Now there is an interactive lab attached to this task that we'll be looking at. The interactive lab will simulate a hotel Wi-Fi network where you have to pay for the services. So let's click on view site so you can have our interactive lab open. Good. So we know that the router is not allowing Bob's packets, which is the blue one, to the website. Let's see, request. It's placing it in the bin, right? You can see. Good. But the one of Alice is passing through. You can see that it's passing through. Good. So what does it? So once we are supposed to deploy. Try changing Bob's MAC address to the same as Alice's to see what happens. So we are trying to do what we call spoofing right now. So I'm Bob. However, I'm going to be pretending as Alice by spoofing a MAC address. Let's see, 2F, right, 33, 39. You can see that Bob's request is passing through now. Good. What does IP stand for? Internet Protocol What is each section of an IP address called? Octets. How many sections in digits does an IP address have? 4. What does the term MAC stand for? Media Access Control. So we're supposed to deploy the interactive lab and spoof the MAC address. So we got our flag already. Triacme, you got. Should I just copy and paste it? Let's do that instead. Oh shit. That's my good day. You got Triacme. Good. Next one, we're learning about ping. Ping is one of the most fundamental network tools available to us. Ping uses ICMP, which means Internet Control Message Protocol. It uses ICMP packets to determine the performance of a connection between devices. For example, if the connection exists or is reliable. The time taken for ICMP packets traveling between devices is measured by ping, such as in the screenshot below. This measuring is done using ICMP's echo packets and then ICMP's echo reply from the target device. Pings can be performed against devices on a network, such as your home network or resources like websites. This tool can be easily used and comes installed on operating systems such as Linux and Windows. The syntax to do a simple ping is ping IP address or the website's URL. So if I want to ping google.com, just type ping google.com. That's all, www.google.com. Good. Now let's see this in action in the screenshots below. We can see the ping and we can see the IP address. Here we are pinging a device that has the private address of 192.168.1.254. Ping informs us that we have sent 6 ICMP packets, all of which were received at an average time of 4.16 milliseconds. So now we are going to do the same thing by pinging the address of 8.8.8.8. Okay, view site. We are going to view site. Excuse me, please. We are going to input the IP address here, 8.8.8.8, and send. Wow. So pinging the correct address will reveal a flag to answer the following question below. What protocol does ping use? ICMP. What is the syntax to ping? So here we're going to type ping. They're asking for the syntax, right? Good. What flag do you get when you ping 8.8.8.8? The flag, you can see the flag here. Triacme THM. I pinged the server. We're done. That's all. It's a very simple protocol to use. Now continue your learning by joining the Intro to Learn room. We complete this and we move to the next one. Okay, Intro to Learn room is a premium room. That means we have to make our subscription. Alright, thank you guys for joining. If you would like to add anything, if you have feedback, you can put it in the comment section. Thank you.